Now my dear students, we can go to the question number 29. Here we can see the question number 29. The measurement of the electron position is associated with an uncertainty in momentum which is equal to 1 into 10 to the minus 18 grams centimeter per second. The uncertainty in electron velocity is, here my dear students, it's a question of uncertainty Heisenberg principle, and you can see the concept and formula is 1, that is we can use delta x into delta p, that equal to h upon 4 pi. This is the formula of Heisenberg uncertainty principle. Now we can see here my dear students, uncertainty in momentum. Here uncertainty momentum means, that is m into delta v, that equal to, which is given in numerical, 1 into 10 to the power minus 8 grams centimeter per second. Now we can see here uncertainty in velocity, uncertainty in velocity, that is delta v, that equal to 1 into 10 to the power minus 18 divided by 9 into 10 to the power minus 28. This is the mass of electron in grams. That equal to, when you can divide it, it's a 1.1 10 to the power 9 centimeter per second. So my dear students, this is your answer, 1.1 or 1 in 10 to the power 9 meter per second. Question number 29, you get answer C. Now my dear students, we can go to the question number 30. Given the mass of electron is 9.11 into 10 to the minus 31 kilogram. Planck constant is 6.626 10 to the minus 34 joule second. The uncertainty involved in the measurement of velocity within a distance of 0.1 angstrom. Here what is the concept and formulas? Here this is the formula is delta x into delta p is greater or equal than h upon 4 pi. Now here momentum is given, mass of electron is given, and Planck constant h is given as uncertainty in the measurement of velocity within distance of 0.1 angstrom. So my dear students, angstrom is converted to meter, 0.1 into 10 to the power minus 10 into mass of electron, delta p, you know the mass into velocity, change in velocity of electron. So mass of electron is 9.1 into 10 to the power minus 31 kilograms into delta v, you can calculate here, and 6.626 into 10 to the power minus 34, he given the Planck constant values upon 4 into 3.14. Now my dear students, you can calculate the delta v. So delta v is a 6.626 into 10 to the power minus 34 upon, these all values are present in below, 4 into 3.14 into 0.1 into 10 to the minus 10 into 9.1 10 to the minus 31. When you solve this, you can easily solve this, 10 minus 10 go above, minus 34 down, minus 31 above, and you can cancel with each other, point is replaced, and first of all you multiply both values 1, 2 and 3 and divide by these values. Then my dear students, question number 30, you can get the answer delta V, that is equal to 5.79 into 10 to the power 6 meter per second. So this is your answer, question number 30, answer is B, 5.79 10 to the power 6. Now we can go to the question number 31. The uncertainty in position of electron, my dear students, formula is same, that is delta x into delta p. Here momentum is directly given in your question, that equal to h upon 4 pi. Now we can calculate the delta x, that equal to h upon 4 pi into delta p. Now my dear students, we can see here h is the 6.62 into 10 to the power minus 34 upon 4 into 3.14 values of pi multiply by the position, that is 1 into 10 to the minus 5 given in the numerical. So, my dear students, you can get the delta x values. Delta x is the 5.27 into 10 to the power minus 30 meter. So, my dear students, question is 31, answer is A. Now, we can go to the question number 32. The de Broglie wavelength of a particles with mass 1 gram and velocity 100 meter per second is. My dear students, formula is de Broglie formula we can use here. Lambda is equal to h upon mb. This is the de Broglie formula. Here h is given 6.626 into 10 to the power minus 34. Your mass is given, that is 1, it is in gram. So, my dear students, it is 1 gram, and this meter 100 meter. So, it is converted to centimeter. So, it is called 1 into 10 to the power 4 centimeter per second. So, you can get here 6.62 or 63 into 10 to the power minus 33. My dear students, you can get the answer. Question number 32, C is the answer. 33 meter. Here this is centimeter is converted to meter, and you can get the answer. Now, we can get the question number 33. The position of both an electron and a helium atom is known within 1 nanometer. Further, the momentum of the electron is known within 5 into 10 to minus 26 kilogram. The minimum uncertainty in the measurement of the momentum of the helium atom. Here, my dear students, concept of question. According to uncertainty principle, according to uncertainty principle, the product of uncertainty in position and uncertainty in momentum is constant, because you can get the delta x into delta p, that equal to h upon 4 pi. My dear student, this is the constant. So, product is the constant. Product is constant. For a particles, that is 1 nanometer particles, both electrons and helium atom is also 5 into 10 to the power minus 26. So, my dear students, your answer is D, because product is the constant. So, when momentum of electron is delta p, that is the minimum uncertainty measurement of momentum of the helium atom. Now, we can go to the question number 34, uncertain position of electron moving with a velocity of 3 into 10 to the power 4 centimeter, accurate up to 0.001% will be. Use the h upon 4 pi in uncertainty expression where. My dear students, what is the concept and formula which are used here? That m is equal to, here m is equal to 9.1 10 to the minus 28 gram, and velocity is equal to 3 into 10 to the power 4 centimeter, and accuracy that equal to 0.001%. 1%. It means that is the 0.001 upon 100. This is the accuracy. H is given 6.626 into 10 to the power minus 27 arc. Now we can see here actual velocity of electron, actual velocity of an electron, that equal to delta V, that equal to 3 into, this is 3 into 10 to the power 4 into accuracy, that is 0.001 upon 100, that equal to 0.3 centimeter, as centimeter, 0.3 centimeter per second. This is the actual velocity. Now, my dear students, uncertainty. Uncertainty in the position of electron, that is delta x, that equal to h upon 4 pi into m into delta V. Now, my dear students, you can put the value 6.626 into 10 to the power minus 27 upon 4 into 3.14 into mass of an electron. It is given by 9.1, 10 to the power minus 28. Here you can calculate delta V, that is 0.3. Then, my dear students, you can calculate the delta x. Here, my dear students, delta x is the 1.93 centimeter, and this is your answer. Question number 34, answer is C, 1.93 centimeter. First of all, you can write the datas which are given in your numericals, then you can get the accuracy, then accuracy of this electron is can calculate, then you can put the values of this mass and get the delta x, because here he want the uncertainty in position. This is the uncertainty in position of an electron, delta x. You can get here. Now, my dear students, we can see the question number 35. Which of the following statements do not form a part of Bohr's model of hydrogen atom? My dear students, the Heisenberg uncertainty principle concept, Heisenberg uncertainty principle, Heisenberg uncertainty principle oppose the Bohr's theory. So, my dear students, it is do not agree. You can see the answer D, the position velocity of electron in the orbit cannot be determined simultaneously. So, my dear students, this is the answer. Question number 35, you can answer D. Now, we can go to the question number 36. 4D, 5P, 5F, 6P orbitals are arranged in the order of decreasing energy. My dear students, you can go to the n plus L values, in which n plus L value is higher, energy of the orbital is higher, energy of the orbital is higher. So, n plus L value for L value for 0 s orbital, 1 for P, 2 for D and 3 for F. So, my dear students, for 4D, n plus L values for 4D, that equal to 4 plus 2, you can get 6. Here 5P, 5 plus 1, you can get 6. Here 5F, 5 plus 3, you can get 7. 6P, 6 plus 1, you can get 7. Here, my dear students, when n plus value is same, then greater the value of n, energy of an orbital is higher. So, my dear students, you can see here that 4D, 5P, 5F and 6F is higher. So, energy of 6p is greater than 5f, energy of 5f is greater than 5p, and energy of 5p is greater than 4d. My dear student, this is the order. You can see this order 6p, here 6p, 5f, 5p and 4d. So, your answer is C. Question number 36, you get answer C. Now, we can see here question number 37. Here angular nodes and total number of nodes. You can see the theory and formulas. Number of spherical or radial nodes in any orbital, that equal to n minus L minus 1, number 1. Number 2, number of angular or planar or angular nodes, that equal to L. Number 3, number of or total number of nodes in any orbital, total number of nodes in any orbitals, that equal to n minus 1 n minus 1. So, my dear students, here you can see that this orbital having 3 angular nodes. If 3 angular nodes means L is equal to 3, these are present angular nodes. So, you can see here 3 angular nodes and 3 total nodes, and here that is 3. So, my dear students, n minus 1 is equal to 3, then n is equal to 3 plus 1, that equal to 4. So, n is equal to 4, and you can see here 5 and 3, 4 and 6. So, your answer is C. Question number 37, you can get the answer. Question number 37, you can get the answer C, 4, because you can get the n is equal to 4. Now, my dear students, we can see the question number 38. In question number 38, which one is wrong statement? Here he want the wrong statement. Here you can see the wrong statement is this one. Why? Because I can see that these electrons. My dear students, all electrons are present in a same direction, 1, 1, 1. Here you can see this electron is present in a different direction. So, it is a wrong answer. Now, we can see here another statement, M for dz is equal to 0, yes, 0. Correct statement, dz is equal to 0. And orbital is designed by 3 quantum numbers, yes, n, l and m. Total orbital angular momentum of electron is s orbital is equal to 0. Because in s orbital no angle is present, so angular momentum is not present. You can also learn in this type of angular momentum. Now, my dear students, we can go to the question number 39. Which one is the wrong statement? Here we can see the wrong statement is the C. Why? Because I see that the energy of 2s orbital is less than that of energy of 2p orbital in case of hydrogen like atom. You always see that 2s is energy of 2s is always lower than 2p. After 2p, 2s is present. So, it is a wrong statement. Now, other statement, de Broglie equation, right. Here half filled orbital are more stable, fully filled. This is the uncertainty principle. Now, my dear students, we can see the question number 40. How many electrons can fit in the orbital for which n is equal to 3? When, my dear students, n is equal to 3 means it is a third orbit and L is equal to 1. My dear students, L is equal to 0 for S, L is equal to 1 for p orbital. So, it is a 3 p orbitals, and in this p orbital we can divide it into px, py and pz. Here, my dear students, you can see 2, 2 and 2. Here total number of electrons are present in 6, but here how many electrons can fit in the orbital for which it is denoted for only one orbit or one 3px or 3py or 3pz. So, my dear students, you can here answer given for 2 because you want the orbital, one orbital. Now, my dear students, we can go to the question number 41. Which of the following pairs of d orbitals will have electron density along the axis? Now, my dear students, along the axis you can see C is the correct answer because dz square, dx square, y square are present. If this is the x and this is the y axis, orbitals are present on axis. So, my dear students, here this is the axis. So, dx square y square are present in this is the structure of dx square y square, and dz square structure is this one z. So, these are always present in axis. Answer is C. Now, we can go to the question number 42. Two electrons occupying the same orbitals are distinguished by only, my dear, spin quantum number. Only this is the number 1, that is spin quantum number. Azimuthal quantum number we can here determine the SPDF. Here principal quantum number we can determine the KLMN, and magnetic quantum number we can determine the orbitals or Px, Py and Pz. These are determined by the M. So, my dear students, your answer is B. Now, we can go to the question number 43, which is the correct order of increasing energy of the listed orbital in the atom of titanium. Here, my dear students, when we go to the titanium is atomic number is 22. So, it is at 3d2 and 4s2 is present. So, my dear students, and all inner orbitals are 4p is empty 0, it is a d block elements. So, here you can see the 3d 4s 3d, you can see 3d 4s 43. Energy of 4s is lower than 3d. So, according to energy, because he want the increasing energy of listed orbitals. So, my dear students, you can go to the answer C, 3s 3p, then 4s, then 3d. Now, my dear students, we can go to the question number 44. The number of d electrons in Fe plus 2 is not equal to the number of electrons in which one of the following. My dear students, you can see that is answer is chlorine. P electrons in chlorine, it is not equal because in Fe plus 2 electrons are going in d orbitals. In neon, electrons are present in p because here d6 is present, here p6. Here magnesium S2 is present, but in chlorine, in this chlorine, you can not get the equal number of electrons in which one of the following, not equal number. So, your answer is D. Now, we can go to the question number 45. The angular momentum of electron in d orbital is equal to, my dear students, formula is that angular momentum of electron is calculated by root L plus 1 and H. My dear students, L is equal to 0 for S, L is equal to 1 for P, L is equal to 2 for D. So, here you can see that 2 plus 1 H, that is equal to 2 into 3 H, and that equal to 3 to the 6 root 6 H. This is the correct answer. So, my dear students, you can go to the question number 45C. My dear students, I can give your all concepts or formulas which are asked in 25 to 35 years questions in NEET exams, and in each questions I give you fully solved questions with the concept, with the trick, with the theory. Now, I hope this chapter is also you can get the lot of things in this chapter. Thank you.